Welcome everyone. It is a lovely Saturday morning here in South Florida, and I am so happy to be making this video. This is going to be a rather short video, but we do have some very important things to cover, and one of them is going to be integer overflow. So you can see mostly we're dealing with signed integers, but in this particular case, this is an unsigned integer, and an unsigned integer is going to be 4 bytes, which is 32 bits. So you can see in the example here that there are 32 bits, but because we're using 4294 all those way up to 297, that's going to exceed the highest value, which is going to be 4,294,967,295. So that would be all ones. But then we have a little problem because now we want 97, which is 2 numbers higher. So you can see how this is being represented in bits over here and with the additional 1. This, if this was 0, would be 96. And the fact that there's one more makes it 97. But now we have 33 bits trying to go into 32 bits. So it kind of just starts all over. So now we have it as a 1. So this is not going to work. So you have to be very, 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 very careful on that. So most of the time, you're not going to have an integer that's going to be over 4 billion. So you don't really have to worry about that. If you're using a signed integer, which is a regular integer, then you only have half of that because half of it has to be negative and then half of it has to be positive. So here we have different explanations in here, and you may get a compiler warning, but you may not get a compiler warning in there. So just be very, very, very careful when you're doing things in here, and they give you a nice explanation here. So we're going to go through a couple of these exercises here, and one thing you can do is run this on your own so you can see how all of these work in here. But let's go through some of these over here. So overflow can occur at any point in a program and not at variables. Exactly. Suppose you had a 4-byte integer and then you added 10 to it, you had the max. So obviously you're going to have an issue. So let's go and choose yes and see what happens. And we're good. So will X cause a flow? Well, this is assuming that it's a 32-bit. Now, what it does not tell you is whether it's signed or unsigned. It just says that it's an integer. So the highest amount for an integer is let's just say 2.5 billion. So this is fine. This is fine. It would be nice if there was comma in here to make it a little bit easier. But this should be well within 32 bits. So let's click and choose yes. And obviously it's not. So the value of 1 billion of X is within the range of 2 billion here. So, oh, actually, I read this wrong. It says, will it cause overflow? So, ooh, bad me. So let me change this back, and we're good over here. So at this point in time, we are going to go back and move on and learn from not reading. There's a perfect example. Make sure that you read before you answer. Now, the good thing about Zybooks is it lets you go back and correct any mistakes in there. So now we're going to do the same thing. Well, 999, 999. So we have 3, 6, 9. So now this is 9 billion in here. Let me just check. That's 3, 4, 5, 6, 7, 8. So 9 billion should cause an integer overflow. So let's go and in here, will, let's see, not only initialization, assume all variables in here. Will this cause an overflow? Yes, it should. And it does. Will this cause an overflow? So we have 0, 0. So now we have a dilemma. Is this going to be signed or unsigned? If it's unsigned, yes, it will be. If it's unsigned, no, it will not be. But if it is signed, it will. So it just says it's declared as an int. So because it's being declared as an int, not unsigned, this should cause thing. And let's go and see. And we're good over here. So let's try one more, and then I'll let you on your own. Will these assignments cause overflow? So we have 1,000 times 1,000, and that happens to be 1 million, so this should not cause an overflow. All right, so you can move on to the next. We're going to do numeric data types. So this is what I was talking about before. Now remember one thing, a character really is an integer. It's just displayed differently, but it's stored exactly the same way. So we have character, my val is, this is going to be only 8 bytes, or 8 bits. So you have quite a bit difference in range over here. It's minus 128 to 127. If it was unsigned, then it would be 0 to 255. But we don't have to worry about that right now. It doesn't say anything about unsigned. And then short, this is 16 bits, and this is 32 bits. So this is what the integer would be. Just think of as a long my bar here. A integer and a long integer are really both 32 bits. And so think of it, this as a long integer and this here as a integer are both identical. You can see it's minus 2 billion to plus 2 billion. So here now we have a long, and that goes up to 9. So just remember long. And basically it's long repeated twice. It's not a typo, and they do tell you that it's not a typo. So let's go in here and choose the number of days per school year to indicate whether it's a good variable for the state of birth, assuming it is usually used for integer. So yes, this would be fine. I would, the number of days per school. So what you could do if you're not 100% sure and you want to be the most efficient, you could go in here, and obviously this would not qualify, but a unsigned character would, because you can go up to 255, and last I heard there's only 180 days of school. But let's just not worry about that for right now, and let's just say that the number of days per school would be good. And the number of days in a human's lifetime. Well, I'm hoping that the number of days in a human's lifetime is within an integer. Let's see what it can be up to. So this is technically an integer. And so we can go up to 2 billion. I don't know of anybody that is 2 billion days old. So let's just go and see what this has to say. And we're good here. So now we have the number of cells in an average human body. I have no idea how many cells there are. I am not a microbiologist, but I can imagine it's an awful lot in here. So the number of cells. So I would go, because this is an integer, I would go false. And now we have the number of human heartbeats in a year, assuming 100 years. Well, you would need to calculate that as, let's see, in a year beats per minute. So you would have to choose 100 per minute times 60 minutes per hour times 24 hours per day, and then times 365. That would be a lot. So would long night beats? Well, let's go and see what long does. And long here can go up to 9 billion. So I'm going to let you calculate that on your own, and you can decide if it's within 9 billion or not. So now we have float and double. For all intent and purposes, float really has been replaced by double because the amount of memory is so vast these days in computers. So this is 32 bits and this is 64 bits, but they're not the same way as integers. So don't get hung up on mantissa. Just look at decimal places that you can have, and it will just tell you exactly how many decimal places are in just a little bit. So hang in there. So we have float as the most common used floating point. That actually used to be true. So let's go with false and see what that has to say. And that's true. And then integer and double types are limited to 16 bits, or 16 digits. Well, that's a little bit challenging here. So 16 digits. So let's see what it says in here. In an integer size processor is not necessarily 30 bits. For every count, at least 32 bits for integer. So 16 digits in here. So are they limited or not? Well, depends what they're talking about. So let's go and see what Zybooks has to say in terms of that. You'll see that shortly when we get into the amount of digits when we start talking into significant digits. So here it is right over here. So you have, due to the fixed sizes of interpretations of minticin, don't get too hung up on that. We have 7 significant digits for float and 16 for double. So what that would mean is a significant digit is anything after the first non-zero. So all these wouldn't be significant. Of course, this is something different, but all of these would be significant in here. So you would, even if they were all 0, it still would get chopped off. So I'm going to leave this for you to answer. And if you don't get it right, it will explain to you exactly what is the correct answer. So we're going to do one more thing. We're going to go to unsigned in here. And this is what we were talking about before. So you have 0 to 255 instead of minus 127 to 128. And this is a lot. So now you have an unsigned long var, which is basically double. So what you would do to determine the difference between signed and unsigned is you would double the signed value and subtract 1. So with the minus 127 to 128, you have to remember that the 0 counts in there. So you would just double that and you would get 128 times 2 would be 256. And then you would subtract 1 and it would be the answer. That's where you get the 255. Because in reality, this is really 256. 0 plus 255. All right, so let's go and just look at this. I will let you go through this on your own in here. So declare a 60-bit unsigned integer value. Well, I'm going to do it wrong the first time. So let's just go. We think it's long. So let's go and do long. And let's do num molecules. And I'll put in the decimal point, rather I'll put in the semicolon. The next time I'm going to leave it out so you can see in here. So because we want a 64-bit, bear in mind that a integer and a long integer are 32 bits. They're 4 bytes, which is 32 bits. So let's click on this and see if it knocks us down, which I'm guessing it will. And it did, unsigned. So this doesn't really help you. So what it really needs to do is long. And that's 64 bits. So let me now take out the semicolon so it can mark us off again. And you can see how good it is at telling you things that are off. So it doesn't like this at all. It doesn't tell us really what's going on. Let's put in the semicolon here, and we're good. And it did not like that. So unsigned, long. So let's see. Here we go. We did not put in unsigned. So I kind of made those mistakes because I want you to get in the habit of reading. Notice it clearly says unsigned integer, and it clearly says 64 bits. So if you go back to the other one, you'll see exactly how it is. So we're good here. So let's try this. They say the third time's a charm. In this particular case, it should be the fourth. And now we're good. So you can see how good that Zybooks is nursing you through and correcting all the mistakes in here. So we want to declare a 16-bit unsigned integer named on. So let's go. A 16-bit is 2 bytes in there. So we can try short. So let's try unsigned. And then I don't remember what it is, and you don't remember what it is. So that's no big deal. Just go back, but it should be short. And here are 16 bits. So you can see this was the 64 bits that we were doing before. So we're going to do 6 unsigned. We're going to do short. And we're going to do num atoms. And of course, we want the semicolon. And here we go. So now this is a little sneaky. They say initialize num of atoms to the smallest unsigned value. Well, this is really easy because it doesn't matter whether it's a short, an int, a long, or whatever it is. The smallest unsigned is always going to be 0. And if it's not 0, I will be very surprised. So let's click here and choose check, and we're good here. So that is all for this video. I hope they are helpful to you. Please make sure to share your comments in the videos. Let me know what you think. Let me know how they can be improved or what you like. And I will see you very shortly.